In this video, we're going to learn about U substitution. It is a special type of anti-differentiation when we have a composite collection of things that we want to find the antiderivative of. It's similar to the idea of chain rule, but there's like kind of a bunch of garbage going on, and we're trying to clean up the thing that we're trying to find the antiderivative of. There's a bunch of gobbledygook going on here, but it's easiest to think about like there's a whole bunch of things we have right now. We want to replace this innermost function with a u and then hope that we can get rid of all of this stuff that's over here in order to get just a du. So let's take a look at some examples. This isn't erased. I need to erase all these. It's like it was never there to begin with. So we want to figure out something along the lines for this function. Now there's a bunch of things going on, but the thing that I'm identifying is that there is this function that's happening inside of this squared. So I'm going to try and see what happens if I use that as my u, my innermost part. So this is u. It is 5x squared plus 1. Now I'm going to figure out what the derivative of u is with respect to x. So the derivative of this thing, I would like this to be a different color, please. Derivative of this thing is going to be 10x plus 1, that goes away, dx, because we found the derivative there with respect to x. But oh, wait, look, that thing is right here. That du is that 10x dx. Oh, how lucky. Sweet. So we can replace that with a du. We can replace that purple part with a u, and then we keep everything else. So this is asking us to take the antiderivative of u squared du. Ooh, that's something that I can do very easily. But what I had before, I couldn't figure out what that was. So we can kind of say, oh, that 10x dx, that kind of goes, ooh, bye-bye. I could anti-differentiate this u squared du. And then once we're done, we'd have to substitute it back in. In this problem, we're again looking for our innermost function. I've got a cosine, I've got a sine, I've got a squared, and I've got a fraction. If I think about like kind of like going on the outside and like working my way in, on the outer part, we've got cosine and sine. And well, we got that fraction. And if I go inside of that, then I've got cosine and sine. But sine has an even inner part where it's sine squared. So there's a squared, and then we get to the sine. So I want to pick sine as my innermost thing. I'm going to try sine as u. Now, if you pick one and it doesn't quite work out, like you're trying to substitute it back and it's not working, try something else. So u equals sine x, and when I take the derivative of sine, it's going to be another thing. Boop, boop, boop. So du is going to be the derivative of sine is cosine. Another reason why I would want to use sine instead of cosine. Now you could think, well, if I take the derivative of cosine, don't I get sine? Yeah, but it's going to be harder to substitute that stuff in. So if I look at my fraction, I do have this. Whoop, oh, that's a terrible line. Let me try that again. Cosine x dx, that's our du now. So du. Then we've got that fraction, and underneath that fraction, we've got that sine being squared. So we've got a u being squared. We still want to make sure that there's something in that numerator, so we'll put a 1. So this is the antiderivative of 1 over u squared. You could clean it up a little bit more if you wanted to and make it u to the negative 2 du. And then that would be a lot easier to integrate than that fraction thing. In fact, I don't even know how to integrate a fraction. I know negative 2, though. Let's try this one, doing U substitution. So I would look for that innermost part. I've got a couple things going on. I've got a fourth, I've got a cube, but I think this fourth thing inside of the square root is the thing I want to try to use for U. Also, I'm thinking about, hey, if I do the derivative of t to the fourth, it'll be t to the third. Yes. Okay. So that'll be U. So it'll be 2t to the fourth, 2t. Then we do the derivative of this thing, and we get, let's see, that's going to be 8t to the third plus nothing, as we do the derivative of 3. And then we get dt, because I'm finding the derivative of that with respect to t. But uh-oh. In the problem that we have, it seems that there is missing an 8. We don't have an 8 over here. We've got a dt, we've got a t cubed, but we don't have this 8. Well, let's just get rid of it. Let's knock it over there with the du. And instead of just putting in a du where that t cubed and the dt were, we're going to put a du over 8 to compensate for that 8 that we didn't want to be there. So let's do that. So we'll have du over 8. And then we want to find the integral of u. And we're going to keep that square root. Now, one of the properties of integrals that you may or may not remember is that if you have a constant inside of it, you can bring it to the front. So that 8, we can actually just kind of go whoop, and we can bring it out front here. So we'll do 1/8 of all of this stuff. So this is going to be, all right, I'm brown now. U to the 1/2 du. Okay. So then we do the derivative, the antiderivative of that. Antiderivative of that is going to be u to the 3/2, because I add 1, over 3/2. But you know what? I'm just going to make my life easier. And instead of dividing by 3/2, I'll multiply by 2/3. That'll just be simpler. Plus some constant c. Now we do want to multiply this thing by that 1/8. And we could multiply the 1/8 by this and the c, but a constant times 1/8 is still a constant. So it's just going to be a different constant. So there's no need to bring that thing over there. The constant just kind of eats it up. So there's no point to distribute it into the thing. If there were more terms, like it was u to the 3/2 plus another u, then that other u would need that 1/8. But the constant doesn't need it. So this is going to be a thing 2/3 times the thing that'll be a 12th. Cancel 4. Yeah, 12th. 1/12 and u to the 3/2 plus c. Now that we've done that, we need to bring that u back because we don't want to leave it in terms of u. What was my u? It was 2t to the 4th plus t plus 3. Okay. So I could rewrite this maybe a little bit neater if I put it up on top of the fraction. So 2 to the 4th, 2t to the 4th plus 3. Actually, I don't want those things. No, well, we'll keep it. We'll keep it as an exponent. It'll be fine. So then we got pen 3/2. This is all over 12 plus c. So that is our integral. Now, and again, it wanted us to check to make sure that that works. So let's find the derivative of this thing. If it works out, we should get back with what we started. So we drop that 3/2 down to here. So that will be 3 time over 2 times 12. Then we've got our 2t to the 4th plus 3. Subtract 1 from our exponent, that's 1/2. The derivative of c is going to be 0. Oh, and I jumped the gun again. I want to figure out what the derivative of our inside is. So the derivative of this inside piece, because I've got a chain rule, is 8t to the 3rd. Okay. So what can we do to simplify this thing? We can cancel this 2 with that 8, so that's 4. We can cancel this 3 with the 12, that's 4. Oh, and then this 4 with that 4, and so all the constants are gone. And so we're left with just 2t to the 4th plus 3, 1/2 exponent, and then a t to the 3rd, which I believe is what we started with. Yeah, 2t to the square root of 2t to the 4th plus 3. Yep. and then a t to the third on the outside. Yep, all works out. All right, so TLDR about U substitution. Your goal is to find that innermost composite function, figure out the derivative of it off to the side so you can bring it back. So you just have the function, the kind of like shell around it, and just a U on the inside. We don't have a chain rule for anti-differentiation like we do for regular derivatives. So we want to substitute things in so we're able to find the antiderivative of things. If the first thing that you try to like U substitute, you try to sub it back in so you just have U's, doesn't quite work out, you might need to do a little work over here with what you've got for du, or maybe just sub in something different. Try something else for your U value and see if that works better. Be careful though, once you are done, that after you do that anti-differentiation, that you bring back that x value so that your answer is still in terms of x or t or whatever you had. All right. Thanks for watching. Goodbye.